Questions often arise about the fluid and particle dynamics within a dental vacuum system. There is an assumption that the movement of liquids and solids mirrors that of standard plumbing. But there are some significant differences. So to show what really happens inside these vacuum pipes, we visited Ramvac in Spearfish, South Dakota. Ramvac, a leading dry vacuum pump manufacturer, has installed a system of transparent piping to simulate a dental office configuration. Watching them in action, we can see that liquids and solids only move through the vacuum system when air moves. So if the high-speed evacuator at the chair isn't open, there is no air movement, and for the most part, materials and liquids in the system come to a stop. Keeping the lines clear will maintain a more consistent vacuum. The purpose of this video is to demonstrate the actual dynamics of vacuum and flow with the help of Ramvac's transparent pipe system.
Today we're showing the importance of flow in the dental vacuum system. The importance of flow of air to the dental vacuum pump moves liquids and solids. And we're going to show how this works by sucking up liquids into a pipe, which is to simulate the trunk line in a dental office, to show what happens when you suck up liquid and then you shut off the suction and the liquid cannot move. And as you open up the suction, it helps clear the lines and move the liquid into the trunk line and down towards the collection tank. And when you shut that, the flow of liquid stops. So if you suck up X amount of liquid, that does not necessarily mean that X amount of liquid will end up in a collection tank. It can sit in the trunk lines because it has nothing to cause it to move. When you open up the suction device, this introduces air into the system, which is pulled back through the collection tank and vacuum pump, and that in turn moves the liquids and solids down the trunk line. As the suction device is shut off, you can see the flow of liquids in the trunk line slows way down and almost stops, causing whatever has been sucked up to sit and not necessarily move. As we introduce air into the system, that air helps cause those liquids to flow back to the collection tank to clear that trunk line of any debris that it might have. A very important item in overhead piping is the diameter or size of the riser pipe. This is very critical because in a dental operatory, there's not much noise and not much going on. It's a pretty quiet environment. And if you get too big a piping going up the wall, you can get a lot of noise from this. In a half-inch riser, as you can see, the liquid will hold in there. You have a little bit of air leakage that lets it go by, but you don't see a lot of tumbling. And when you open up the suction device for several seconds, it will clear that line. If you get into overhead piping and you have a riser that is larger than ½ inch, this being 3/4 inch, you will get a tremendous amount of tumbling from air leakage through the HVE or possibly through the trap into the pipe, and the liquids will not clear the line. And when this happens, you will have a tremendous amount of noise. It'll be a water-type gurgling sound, and it's very loud in the operatory. And we get a lot of comments on this as to why it's doing this, and it basically is the riser pipe is too large for the liquids to clear. The first shots of the vacuum system that we showed you were at the chair that would be located the farthest from the vacuum producer. The liquids that are sucked up in that line would go into the trunk line and travel from there all the way to the collection tank. Well, we all know there's more than one chair in a dental office, so if we get closer to the vacuum system and get located approximately in the middle of the trunk line, there's a different effect of what the liquids do when they get into the trunk line. It will actually stop the liquid flow that is coming to that chair from the farthest away chair and let the liquids flow from that chair on, so it actually holds stuff in the trunk line. And as we suck up liquids, you'll be able to see how this works in the trunk line. And as you can see, as it gets into the trunk line, it actually goes both directions. It flows towards the collection tank, and it does flow back towards chairs that are the opposite direction. Now the liquid that's in the trunk line that's away from the collection tank will just sit there, and any solids that are in it could settle in the trunk line. All the liquid that's going into the trunk line towards the collection tank will flow because it has air being introduced into the system to help with the flow of the liquids and the solids. When you shut this off, gravity takes over, and then the liquids will flow, and if the slope of the pipe isn't correct, the solids may build up in the pipe and not flow towards the collection tank. As liquids are introduced into the trunk line from the dental chairs, in a normal dental office you're going to have piping that is 1.5 or 2 inch under the concrete. The piping we're going to show you here for demonstration purposes is above ground and clear so you can see what actually happens in the piping. As the liquids are introduced, it takes quite a bit for the pipe to fill up before the riser that comes up to the collection tank will allow the liquids to come up. The liquids will come from the main trunk line up the riser, which would be coming up out of a concrete floor, into an amalgam separator that's located by the collection tank, and then through the amalgam separator into a collection tank. Sometimes we get small amounts of liquid that come in, and other times we get large amounts of liquid that come in, depending upon how much air is introduced into the vacuum system from the chairs or the high volume evacuators, which allows the liquid to flow into the amalgam separator and into the collection tank. When you suck up liquid with the HVE, it travels into the trunk line and towards the collection tank. As long as the HVE is open, the air traveling through the trunk line will cause the liquid to continue to flow towards the collection tank. When the HVE is closed, the air flow stops and the liquid slows down and can lay in the trunk line, leaving debris to settle in the pipe, causing buildup. An example of this would be if you sucked up a gallon of liquid at the dental chair, you would not get a gallon of liquid into the collection tank. It would lay in the trunk line, and some of the liquid would evaporate into the air as the air flows by going to the collection tank. Basically, just because you suck up X amount of liquid, that does not mean you will get that same amount of liquid into the collection tank. Some of it will get there, some of it will lay in the trunk line, eventually getting there but letting the solids separate out. A certain amount of it stays in the trunk line and just gets washed through as more liquid comes in.
You should now have a better understanding of how liquids and solids flow through dental vacuum lines. Since air movement is what drives flow in a dental vacuum system, an understanding of vacuum dynamics will help you prevent the buildup of solids, which can impede airflow through the line. More air movement translates into better flow, more consistent suction, and hopefully a more effective vacuum system.